This next module focuses on dimensional analysis, which is a tool that we can use to make conversions and to calculate dosage. And it's one of the most important things you'll learn in this course because it's something that's widely used throughout the course, especially the dosage unit. So instead of just saying this is dimensional analysis, use it, I'm going to show you where it comes from, and I'm going to use what we've already been using, and that is ratios and proportions, to set the scene. So here we're saying a patient weighs 73 kilograms. We need to use this information and what we know about ratios and proportions to set up this conversion to pounds. And we're going to rearrange this for the unknown quantity, and I'll show you what I mean by that. So what we want to do is change 73 kilograms into an appropriate amount of pounds, is what we're looking to do. If we were to set this up using a ratio, or ratios and proportions, we know that there are 2.2 pounds for every 1 kilogram. So we saw last week that we start with this ratio, and we are looking, in this case, to convert or change into an unknown number of pounds. So I'll put that here as X, that's my unknown variable, and we are looking for an equivalent amount of 73 kilograms. So again, this was a review of last week. We have this conversion factor. This ratio needs to hold because this is the relationship between these two units. And we want to find an equivalent ratio, but instead of 1 kilogram, we have 73 kilogram. Now we know we could cross multiply, or we could look at how the units on, in the one ratio are changing, what factor, or we could look across, kilogram to kilogram, how that's changing. But what I'm asked to do in this problem is to set this up and then solve for the unknown quantity. So what I mean by that is I want to get this X by itself. And this is a review of what we saw during the first week of the course. So what I'm going to do that is, if I'm dividing this unknown quantity by 73, I'm going to multiply both sides by 73 kilograms. So I'm going to multiply this side by 73 kilograms. And I know if this is going to remain the same, I need to multiply the left-hand side by 73 kilograms. So what I get on the right-hand side is just my X, and that's just pounds. And on the right-hand side, I get 73 kilograms times, and this is 2.2 pounds for every 1 kilogram. So all I did here was just rearrange this, and I know if I wanted to find X, this is the expression I would need to simplify. I would just do 73 times this. It would just be 2.2 because 2.2 divided by 1. But let's interpret why this makes sense. This is 73 kilograms. That's what we were starting with. That's what we were asked to convert. And this 2.2 pounds to 1 kilogram is just the ratio. It's a unit ratio. It's telling us the number of pounds per kilogram. It's saying there are 2.2 pounds per 1 kilogram. So this statement here, 2.2 pounds per 1 kilogram, is saying if I had 1 kilogram, right, we know that the equivalent amount would be 2.2 pounds. If I had another kilogram, this would be 2.2 pounds. So we're saying that we have 73 kilograms. And we know that each one of those kilograms, if we were to break it into these blocks as I was doing up here, each one of them would be plus 2.2, plus 2.2. And we would do this a total of 73 times because we have 73 kilograms. So what operation is this? This is 73 times 2.2. So what we're trying to get at here is we're taking this amount and we're multiplying it by the unit ratio, the amount of pounds per kilogram. If I were to consider just a very basic example, if I was buying 5 bananas and I was told that it was $2 per banana, then I know I can multiply these, right? It's $5, or excuse me, 5 bananas, and each one is $2. So I would do 5 times 2. It's dollars per each single banana. That's exactly what we're doing here. We're taking what we're starting with and we're multiplying by a unit ratio where the units line up. The denominator is per kilogram, and that's what we're trying to cancel out. So we didn't even do this, right? We didn't do this multiplication, and we can do that right now. 73 times 2.2 is 160.6, and this would be pounds. Let's attach this again here to this next example. Use what we noticed above. We took what we were starting with. So we're starting with what we want to convert. So start with what you want to change. And in this problem, what we want to convert is 5 tablespoons. So we're starting with 5 tablespoons, and I'm going to multiply by a unit ratio. And specifically, that unit ratio needs to give me some information based on the number of fluid ounces. And what I'm specifically looking for is how many fluid ounces are there in 1 tablespoon? That's what I want to know. How many fluid ounces are there in 1 tablespoon? And if I can multiply by that, if I can multiply, in this case, if I can multiply by some ratio where I have fluid ounces, so I'll just abbreviate that OZ for fluid ounces, per tablespoon, if I can multiply by this unit ratio or this conversion factor, then tablespoons would cancel and I would be left with just the amount of ounces. And this is a conversion to memorize. We know that there are 2 tablespoons for each 1 ounce. So if I multiply here, if I were to simplify these, 1 divided by 2 is just 0.5. So actually, we could have also wrote 5 tablespoons times 0.5 ounces per 1 tablespoon. This is a conversion factor that others memorize as well. So we're taking what we want to start and change, and we're multiplying by the conversion factor or the ratio where we have the unit that we're canceling out in the denominator, because that's telling us, it's giving us information, the number of ounces per tablespoon. So 5 times 1/2, if you multiply those, you're going to get 2.5, and we know that's going to be in ounces. Let's look at one more example where we can actually take this information and build on it. We can actually have multiple conversions in one step. So let's see what I mean on the next slide. On this slide, we're asked to convert 3,256 grams, which is the weight of a newborn, and convert this into pounds using what we know about unit ratios, which we'll also be referring to as conversion factors. If you recall from previous modules, when we wanted to go from grams to pounds, we actually converted to kilograms first, because this grams directly to pounds was not a conversion factor that we have to memorize, and it's not one that is typically known. But grams to kilograms, that is just a metric system, and then kilograms to pounds is absolutely one you need to know. So what we want to do is use what we just talked about on that last page. We want to start with what we want to change or what we want to convert. So in this example, we want to convert 3,256 grams. And what I'm going to do is first multiply by a unit ratio and turn this amount of grams into kilograms. So I just saw on the last page that if I can multiply by a unit ratio or a conversion factor where the unit of grams is in the denominator and another unit's in the numerator, in this case kilograms, if I can multiply here grams times this unit ratio, I know that this will change my value from grams into kilograms. And the reason why is because this conversion factor is telling us the number of kilograms per 1 gram. Once we simplify this division, that number is telling us the number of kilograms per gram. So now let's put in what we need in here. What's the ratio here that we are looking for? We know there are 1,000 grams in 1 kilogram. So think about what we just did. If we take 3,256 grams and multiply it by 1/1000th, that would change this number of grams into kilograms. The reason why, because there is 1/1000th of a kilogram per gram. So if I were to stop right here and just multiply this, what I would have is the converted number of kilograms. It would change grams into kilograms. The good thing about just multiplying by unit ratios here is actually we can move forward. We can actually do an additional step. What I mean by that is we can now multiply. I know if I were to stop right here, and I'm going to just draw a dashed line, this product right here will change my grams into kilograms. So I know at this step, when I multiply here, I will have a unit of kilograms. So what I want to do is actually get into pounds. So if I take this whole thing and multiply it by another unit ratio, specifically if I can multiply this whole thing by a unit ratio where I have kilograms in the denominator and pounds in the numerator, this unit ratio is telling me the number of pounds per kilogram. So this here in the red box was going to be, when I multiply, give me the total number of kilograms. And I'm going to multiply by the number of pounds per kilogram. And I know that. I know that unit ratio is 2.2 pounds for 1 kilogram. Again, we're using unit ratios. Taking this quantity, and when we simplify it, it would be the unit ratio, a number of grams per, or kilograms per gram, and 2.2 for each 1 kilogram. We divide these, we get the number of pounds per kilogram. We now can multiply, and what we find happens is grams will cancel and kilograms will cancel, and we'll be left with a unit of pounds. So if we put this all on the calculator, and this is a nice review because we're going to be multiplying essentially fractions here. This quantity, 3,256, it's very similar to just writing it over 1. So what I can do is multiply the numerators, 3,256 times 1 times 2.2. And what I get there is, if I just multiply all the numerators, 7,163.2. And now if I multiply all the denominators, 1 times 1,000 times 1 is just 1,000. And when I divide that 7,163.2 by 1,000, I get 7.1632. And this now is in pounds.